All right. In this video, we're going to do a little more practice with the quadratic formula. All right. So I would suggest you get out some paper and jot these down and work through them as I go through. Again, calculator as well to make sure you know how to enter in everything correctly into your calculator. So again, up on the top here is our quadratic formula that we talked about last time. So x equals the opposite of b plus or minus b squared minus 4ac. All of that is going to be divided by 2a. So again, when using the quadratic formula, as long as you can identify the a, b, and the c, the rest of it is just plugging all those numbers in correctly and doing your calculator work correctly to find your solutions. All right. Couple things we talked about. Again, your quadratic equation has to be equal to 0, so we can identify the a, b, and c. In the first example here, we have 3x squared plus 5x minus 2 equals 0. So this one is in the correct form, what we call standard form. And when it's in our standard form, we can identify the a, b, and c. So in front of the x squared term, that one is my a. In front of the x, that one is the b. And the constant at the end here, this is the c. So now that we know what all the a, b, and c are, we can go ahead and we are going to try to find the solutions. So we're going to start plugging into our formula. All right. So x equals, we need the opposite of b. So that would be -5 plus or minus, draw a big long square root sign here. We need b squared, so 5 squared minus 4, all right, times a, which is 3, and times c, and again, take the sign with that, which would be a -2. All right, and all of this is going to be divided by 2 times a, which is 3. All right, so we plugged everything in, and now we're going to do a little work on our calculator. And you kind of have to do it in little parts. So I'm just going to keep the -5 out here for a second, put my plus or minus sign. All right, I'm going to go ahead. I'm going to do the denominator way. That's kind of a simple little calculation. 2 times 3 is 6, so we're all good with that. And now I'm going to go ahead. I'm going to calculate everything here. Again, this is what we refer to as the discriminant, which is everything underneath the radical. All right, so either in your head or if you want to do it in your calculator, we have 5 squared minus 4 times 3 times -2. All right, and that gives me a 49. All right. Now, a couple things. Again, my 49 was greater than 0, okay, which at this point, as I'm working through, I should remember that. That means I should have 2 solutions to this. So if your discriminant is greater than 0, we should have 2 solutions. Okay, so I keep that in mind as I keep going here. 49 happens to be a perfect square, which is nice. So since it is a perfect square, we can go ahead and take the square root of that. -5 plus or minus. The square root of 49 is 7. And again, that is all over 6. All right. Since I have 2 solutions, we can go ahead and calculate this. Again, we go through one time with the plus sign, and then we're going to go through the second time using the minus sign. So we have first time through, I'm going to go -5 plus 7 over 6. All right, so if we have a -5 plus a 7, that gives me a 2. And then 2 over 6. You could go decimal if you want. I'm just going to leave that as a fraction. 2 over 6 would be 1 over 3. Okay, so there's my first solution. My second solution, we're going to go through, and this time we're going to use the subtraction sign. So we have -5 minus 7, again, all divided by 6. So we have -5 minus the 7, which is -12. -12 divided by a 6 will give me -2. Okay, so my 2 solutions to this, my first one that we came up with was 1/3, and the second one that we have is -2. All right. That problem was similar to the ones that you practiced on the homework. The ones on the homework, you hopefully got a lot of nice perfect squares underneath that radical. So you could kind of do the same thing that we did here on the first homework assignment. The next examples that we're going to take a look at are, maybe I'm going to say a little bit harder, because what happens if this isn't a nice perfect square? How do you do it then? And we also talked about like what happens if we get a negative under there. And again, that's going to bring our imaginary numbers in here. Okay, so we need to know how to do those as well. All right. All right, second problem that we have here. All right, so copy this one down. We have 2x squared plus 3x minus 4 equals 0. Okay, again, this one is in standard form, equal to 0. So we are ready to go. Identify our A, B, and C. So again, A is in front of the x squared. So in this case, our A is 2. Our B is in front of the x term. So our B is 3. And our C is our constant in this case, which is negative 4. All right. So let's plug them in. Opposite of B, negative 3, plus or minus, square root. We need 3 squared minus 4 times A, which we said was 2, times C, which again is a negative 4. And all of this is going to be divided by 2 times A, which again is 2. All right, so that's what it looks like when we plug it in. Again, we're going to do a couple little pieces here. All right, and again, I'm going to multiply my denominator right away. 2 times 2 is 4. Get that done with. And now again, I'm going back to our discriminant here. What's going to happen underneath that square root? All right, so we have 3 squared minus 4 times 2 times negative 4. All right, so we have 41. All right, so this is what I was talking about. In example number 1, we had a nice perfect square. The square root of 49 was 7. Okay, we can do that. For this particular one, we have the square root of 41. All right, 41 is not a perfect square. So when you get a number that's not a perfect square, what you want to just look at it and see if you can simplify it at all. Okay, so are there any perfect squares in 41? Okay, as far as factors. Okay, and I do believe there are no perfect squares in 41. So that would be what we say, we would call that simplified. So there's nothing else you can do with that. All right. So if this was my problem, this is okay to leave your answer like this. Okay. This would be what we call it's in simplest form. Okay. Simplest, I guess this would be in a very exact answer. If you wanted to get 2 answers similar to what we did in this first one, okay, they will be decimal answers, and we would have to round them off, which makes them not quite as exact. So you can leave it like this is acceptable, or what you can do is just like we did in this first one, is go ahead and we can enter this in our calculator to get approximate decimal answers. So let's go ahead and let's do that. All right, so we would have negative 3 plus the square root of 41 all over 4. All right, and again, we can do this in our calculator, which is what I'm going to do. So go ahead and punch this in your calculator in the numerator. And then when you get to the end, make sure you hit the equal sign, and then we'll divide by 4. All right, so I'm going to take my negative 3 plus the square root of 41, hit the equal button first. Okay, and you'll see a decimal fills the whole screen. That's my square root of 41 plus my negative 3. And then we can go ahead and divide that by 4. All right. And if you did that correctly in your calculator, I'm looking at 0, I'm going to say 0.85. And we'll round to hundredths. We'll keep 2 numbers after that. All right. So again, this right here is what we would say is the exact answer. This we had to round off a little bit. All right. To find the other one, we could do the same thing. We have a negative 3. This time we're going to subtract the square root of 41. And again, we'll divide that all by 4. All right. So again, enter in your -3 minus the square root of 41. Make sure you hit the equal button first. All right, and then you can go ahead and divide by 4. All right, and this time I have -2. Again, it fills the whole calculator screen. We're going to keep 2 numbers after the decimals, so I'm going to go -2.35. All right, so these would be my approximate solutions because I did have to round those off. This right here would be what we call the exact solution. Okay, we didn't do any rounding, so you can leave it like that if you'd like. All right. Okay, so let's take a look. Number 3. All right, so write this one down. For number 3, we have x squared plus 2x plus 5 equals 0. All right, again, similar to the first two, this one is in standard form. Everything's over here on the left. We have equals 0 over there on the right. So again, we are ready to go. I'm going to go ahead and put a 1 in front of my x squared. That means 1 is my a value, 2 is my b value, and 5 is my c value. All right. Okay, here we go. X equals opposite of b. So we have -2 plus or minus. All right, we have b squared. So that's 2 squared minus 4 times a. A is 1 times c. C is 5. All right. All of that is divided by 2 times a, which is 1. All right. So again, similar to what we just did on the front, we're going to kind of break it up into its little parts. We're going to go ahead. I'm on 2 times 1. My denominator is 2. Again, let's figure out what our discriminant is here. So we've got 2 squared minus 4 times 1 times 5. All right, I've got a -16. All right. Now, this is why we spent a couple days talking about imaginary numbers. This is going to be one of those situations, as explained when we talked about the discriminant. Since my discriminant is less than 0, this would have no real solutions. Okay, so again, if you think about what that means when we talked about our graphs, if it has no real solutions, okay, and again, the solutions are where it crosses the x-axis, this would probably be a graph that looks something like this. Okay, here's my vertex, and my vertex or any part of the parabola will not cross the x-axis. So this is what we mean when we say it has no real solutions. The reason why it has no real solutions is because we have that negative underneath the radical. All right, now we can simplify this a little bit, so you had some assignments like that. If you ignore the negative for a second, the square root of 16 is 4. The square root of a -16 would give me 4i. All right, so we can say x equals -2 plus or minus 4i, okay, all divided by 2. Okay, now because you have the I, you cannot punch this in your calculator at all. -2 plus or minus 4i over 2 is our answer, and that's about all we can do with it. Sometimes you can simplify it. For example, in this one, here we have a 2, and here we have a 4. Our denominator is 2, so sometimes you can like simplify the fraction a bit, which is what we're going to do here to make it look a little bit better. If you, and again, kind of think of it as little parts. If I have a -2 divided by a 2, that would just give me a -1. All right. Then I have a plus or minus. And then if I look at this part, if I have 4 divided by 2, 4 divided by 2 is 2. And then I still have the I. Okay. So this was my answer. This would be what we say is our simplified answer. Okay, so again, whenever you have fractions or radicals, you always like them in what we say a simplest form. Okay, so if you can simplify it, go ahead and simplify it. This would be my final answer here. Okay, if you want to think of it, like I said, what I was doing was just kind of breaking it down into two parts. This is what we did. Okay, so those were my two parts. So again, here's my -2 over 2. That's -1, 4 over 2, and that's our 2i. So if you need to write it out so you can see those two separate parts to help you simplify, that's fine as well. All right. All right, last one. All right, so example number 4, if you want to jot this one down, we have -4x squared plus 6x equals 3. All right, so this one, again, first thing we have to do, a little bit different, a little extra than the other ones. You'll notice it does not equal 0. So you do need to make sure that it's in what we say is, again, standard form. So we're going to take this 3, we're going to move it over to the other side. This is a positive 3, so I would subtract it over. So we have -4x squared plus 6x minus 3 equals 0. All right, now we are ready to identify our A, B, and C. Our A value, -4, B value is a positive 6, C value, -3. All right. So X equals opposite of B, -6, plus or minus. All right, we have square root of, we need B squared, so 6 squared minus 4 times A. A is -4 times C. C is -3. All right, all over 2 times -4. That's my A. Okay. So we're going to do a little work under the radical in a second. I'm going to go ahead and multiply my denominator. 2 times -4 would be a -8. All right. So without hitting the square root button, again, we're just going to do this part underneath. That's our discriminant. Again, let's punch that in our calculator. So we have 6 squared, 6 squared minus 4 times -4 times -3. All right, this time I have -12. Okay, so we're all done calculating what we can. Again, you cannot put -12 in your calculator. You're going to get an error of some sort. I think it might say domain error. So similar to the last one, we're going to have to do some work with this radical, and we're going to simplify it. Okay, again, you always want to simplify your radicals if you can. Always want to simplify your fractions if you can. All right, so how can we simplify this square root of -12? Okay, and again, this is something that we did quite a few problems on the other day. So how do we do this? You want to think of any perfect squares that are factors of 12. Okay, and you want to break it down. So I'm going to write this as the square root of -1 because the square root of -1 is I. All right, and how can I write 12? Using perfect squares. Now, a lot of times people will think, oh, 12 is 6 times 2. Yes, 12 is 6 times 2. However, 6 is not a perfect square and 2 is not a perfect square. Okay, so that doesn't really help you. 12, though, I can say is 4 times 3. 4 times 3 is 12. Okay, and 4 is a perfect square. All right, so when I do this, my square root of -1 becomes the I. The square root of the 4 becomes a 2. 3 is not a perfect square, so that would just stay the way it is. Okay, so after simplifying my radical, this is what I have left. I'm going to put the 2 in front of the I. Okay, so now I'm going to go back over here where we started. We have -6 plus or minus. I'm going to write this as 2I square roots of 3. Okay, and our denominator is -8. All right, So we simplified our radical. I know you might not think it looks any better, but that is what we would say is simplified now. As far as the fractions, looking at some of the numbers that I see a 6 over an 8. I see a 2 over an 8. Again, those are fractions that I can simplify. So again, we're not quite done yet. So again, like I did on this one up here, you want to think of it kind of like in two parts. So I'm going to go ahead and separate it so you can see it. So we're going to think of this as -6 over -8, okay, plus or minus 2i squared roots of 3 over -8. Okay, and then we can just kind of simplify each fraction one part at a time. Negative divided by negative here would be positive. Is 6 over 8, if I just want to simplify that fraction, would be, they're both even here, so we could say 3 over 4. Okay. Plus or minus. This is still going to say plus or minus. We have to worry about that. And then we have 2 over an 8. Okay. For this part here, because of the plus or minus and this minus, you don't really have to worry about that. So we're just going to worry about the 2 over 8. 2 over 8 would be the same as 1 over 4. Okay. And my I squared to 3 is still in the numerator. Okay. So you could put 1i if you want. I'm just going to put I squared to 3 over 4. Okay. This would be my answer, again, in what we refer to as simplest form. You can leave it separate like we have here. If you wanted to, you could put it back together like we did up here. So either way is acceptable. You could say it this way, 3. Okay, those are both okay as far as how you want to leave your answer. But again, you always want your answer in simplest form. The radicals should be simplified. The fractions should be simplified. All right. Okay, those are the 4 examples I had to show you. On your homework tonight, you will run across some that you have I in. So you are going to have to simplify using the I. You may have to simplify like we did here with the 12. Okay. And then you will also probably run across some where it may look like this, where you will end up with that radical in your answer. Okay, like we had here with that square root of 41. And if you would like, you can, like I said, keep it like that. If you would like the decimal answer, you can go ahead and plug that part into your calculator to get a final decimal answer. All right. Thank you.